Excellent. Well, good morning, good afternoon, good evening. Pete Bernard here, CEO of Edge AI Foundation. Today we have our special guests from EMASS and Mohamed and Mark, and I'll let them introduce themselves and where they're calling in from. So, Mohamed, do you want to start?
Yeah, sure. Hi, everyone. Thanks, Pete, for this wonderful conversation we're having now. My name is Mohamed Ali. Right, I'm actually originally from Egypt, Cairo, where I'm right now doing a little bit of work here and also spending the summer. You can see the tan on my face. But I'm the founder of EMAS, which is a Singaporean spinoff from my research work at NTU Singapore. And we are very excited, at this point in time, where we're reaching the fruition of what we started. It's basically a fabulous semiconductor edge AI system, right? We're looking to the transistors all the way down to the application levels. So yes, that's a little bit about me. My profession, I'm a professor, but I decided to take a venture in the startup world, and here I am.
Awesome. Sounds good. Mark, welcome.
Hi. Hello. Well, nice to be here, Pete. Thanks for having us. So I'm Mark Goranson, CEO of Semiconductor Division. And basically, I have 46 years of semiconductor experience, 20 plus with Intel, number with 11 with On Semiconductor, 7 with Freescale, a whole myriad of different semiconductor companies. I was actually retired and enjoying scuba diving, etc. And then NanoView called me up and explained the technology and the company, and I got looked over all the data, did a lot of benchmarking of Mo's product that he had developed. And I said, wow, this is a great technology. Edge AI is like the perfect space at the perfect time. And so I said, this is too great of an opportunity. It's going to be a lot of fun to be able to take this technology and commercialize it and take it to market. So that's why I'm here. And so far, I'm enjoying every minute of it.
Fantastic. No, that's great. And so it's, so folks may not have heard of EMAS yet, but so you spun out of some research that you were doing in Singapore.
Yes, exactly.
And then also, so you're also owned by NanoView, right? Has acquired.
Yes.
And NanoView is based in Perth, Australia, as far as I understand.
Yes.
So we got Australia, Singapore, Cairo, California. Everyone's
everywhere.
So yeah, it must be tough to kind of coordinate some of your time zone calls and stuff. But
one of us has to suffer either early morning or super late.
Right. Yeah, someone has to take the short straw. Do that. Yeah. Actually, I spent a lot of time in Singapore earlier in my career. I haven't been there in a long time. I was just talking to a friend of mine yesterday who's doing some interesting work there. I guess there's a good show there called GITEX or GITEX, G-I-T.
GITEX actually was in April.
This past year.
Yeah. And actually we participated in it. We had a booth in it and we participated. Yeah.
Yeah, I heard it was pretty cool. So maybe next year I'll have to head out there. Get back to Singapore and stuff. So yeah, cool. So you were doing this research at EMAS, you're in Singapore. And so what's the origin story here? I mean, what was the impetus to spin this thing out? And when did you know that it was like, this needs to be a thing. This needs to be a company.
Yeah. So when before coming to Singapore, right, I was at Stanford, right, the postdoc researcher. Then I landed here in Singapore. And then they were interested in AI hardware, right? And the idea that I proposed to them, we have to really push the efficiency envelope, right, for all of these next generation, and that back in 2018. You have to look at the entire computing stack from the applications all the way down to the use of emerging nanotechnology devices. So we created a research program out of that and had many of the higher research institutes in Singapore. And started doing the work, publications, patents, and then we said, hey, this is actually very cool, but let's try to see if this can be applied in the edge AI hardware, because we think that that's where the highest volume, that's where the efficiency is going to be the key in this aspect.
Right.
So we did first chip, right, and then we showcased the results. We said, okay, this is really valuable, and I think the market would be accepting it. And that's where the edge AI was starting to be introduced right in the market back in 2019. So I said, okay, you know what? We're gonna go ahead and let's create a startup company, right? And it was a huge risk because me shifting from the academic world down to the industrial world, right, and building the company myself, it was really a big risk. So we founded EMAS in 2020. We raised some government fund to fabricate the chip that we have right now, and then we were trying to get VC money all the way. We're like some success stories with basic venture build money. Then in 2024, where we got introduced to NanoView, and they see the value of this one, so they said, okay, you know what? Let's combine forces and work together and really accelerate this to commercialization. So then they started acquiring us, and 2025 March, that's when the official merger happened. So the technology itself, yeah, I mean, was like, I mean, how to say that, was like began in 2017 or 2018 when I was at Stanford, and we had a couple of publications back then. But then it took us that time to really de-risk all the technology aspects in it, and now we have the working chip. Actually, we're building another one, but now it's all about the go-to-market strategy and reaching out to customers.
Sure.
Yeah.
And that's where I suspect Mark comes in with how we get this thing sold. It's in volume. And so I also noticed it's RISC-V based, which is really interesting. And,
yes, indeed.
And I'm curious about in terms of where this thing lands in the market and what it's applicable for. I mean, obviously, efficient AI efficiency is currency, as they say. So it is the next frontier in AI is efficiency, and using this RISC-V architecture. So is this, where do you see this thing really being? What are the canonical scenarios that this chip really shines at? In what industries would you say? And that's for either Mark or Mohamed or either one.
So yeah, this product is uniquely positioned to actually go into anything that is power constrained, meaning anything that uses batteries, and batteries are key because it's actually one of the lowest power processors on the planet. It actually is anywhere between 10 and 100 times more efficient than any other processor. Which means that you have a lot more battery life than any other technology. And a lot of these different microprocessor companies, they actually say that they're low power, while we're actually really low power while we're under load, which means that while we're doing the analysis, we actually use low power. So a lot of our competitors like Ambic, Sentient, etc., they say that they're low power, but that's actually in standby. Anybody can be low power in standby, and
sure, shut everything down. Super low power.
So anything that's wearables, drones, etc., that's where we're best positioned against anybody else because, like I said, if you can have now all of a sudden anywhere between 20 to 100 times longer battery life, that's actually very key for wearables and drones, and etc. So. Those are the marketplaces where we actually shine compared to any competitor.
I see. Yeah, no, and so we have a lot of partners in the foundation that are sort of like pushing that envelope. I mean, would you say this is like is it a neuromorphic kind of computing architecture category, or is it something different, or what are kind of the model architectures that you're really optimized for?
Yeah. So, I mean, in what we're doing here, we're leveraging what we call the near memory computing, right? Not neuromorphic in-memory computing. We're doing near memory. So how we can interweave the compute and memory components so close together while providing very wide connectivity and very fast access to the memory. So that is one of the key things that we are leveraging on from the architectural level. Then we're taking also some of the advantages in the emerging memory devices and logic devices. And we are working on like leveraging their advantages and suppressing their shortcomings through innovations in the architecture and system level. So we're not waiting. So the technology, we can use it as it is, and we try to work out some of the kinks from the circuit architecture and system level. Then we're looking at how the hardware software co-play. So we do optimization in the software, and then we build a specific hardware module to even accelerate their execution and streamline the data path inside the system much faster with a more smaller footprint and lower battery life, lower energy.
Got it. So you're really sort of I mean, one of the big challenges, as you know, maybe the listeners don't know, is the separation of memory and compute is one of the things that really kills kind of, low power, high performance AI. And
Yes.
so the closer you can get the memory and the compute together, in fact, there's this concept of in memory compute and things like that, right? That people are working on. So it sounds like that's one of your secret sauces, is how to get the memory and the compute as close
Right.
together as possible.
Yes, exactly. Yeah. So we're doing this while at the same time understanding that, in-memory computing and neuromorphic computing is one of the things that we might use, but we taking advantage that we're using like memory as blocks and compute as blocks, but how you split things and slice and dice things very close together. That's our secret sauce.
Yeah, no, that's cool. So what's the software story, like the tool chain? And, one of the challenges, I was just talking to a partner, I won't name them, struggling with tool chains and model portability. And, how do you approach that from a developer who's saying, hey, I'm doing some stuff on CUDA, or I'm doing some stuff on OpenVINO, or I'm doing some stuff on Dragonwing, Snapdragon. Like, how do I move to this platform? What's the story?
Yeah. So, I mean, one thing that we always think about, right, when if you have this chip, right, I don't want to reinvent the wheel or having like a huge, right, ramp up of like tool usage, right? This is going to be a big kill for the system. So we want to make it as compatible as we can, right, with existing tools and frameworks.
Sure.
So since it's an edge AI, our main goal was to make it compatible with the most common AI suites. So TensorFlow, PyTorch, right? Onyx Cafe. So we have the engine that will take the code that's written in there and will convert it to the right programming sequence to the AI accelerator. So that part is done. We've been testing it into various like convolution networks, fully connected layer, and we keep adding more support to it, right, as we test more and more kind of these kind of workloads. But we always make in mind that you can have the lowest energy chip in the world, right? If it's programming it, it's going to be tedious, or it's not easily integrated with the existing tool flow or suites. I mean, you're shooting yourself in the foot. So we always try to make sure that, like, okay, an engineer will take it. He doesn't even need to know, right? And especially the AI engineer doesn't even need to know that he's doing it for our chip or another chip. It is up to us to have the backend engine to translate what's written in TensorFlow, PyTorch, all the way down to the right binary, right, that can be run onto our chip, including any kind of software optimizations that we are providing.
Right. Okay, got it. So you're providing sort of the translation layer, the recompilation technology, so that they can use their favorite frameworks and tools on top, and it all happens underneath. Well, that's pretty cool. So, I mean, here's a question for Mark, is like, so when you're going after these markets, are you going after the developer market, or are you more of like, I'm going after someone who's building this agricultural equipment or aerospace equipment? And what's the kind of general approach been?
Yeah, our general approach right now is to go after OEMs, and this is the agricultural developers, it's the tool developers, it's the wearables, so it's the drone manufacturers. We have some proof of concepts where we can actually improve flight time with drones over 30%, and I think ultimately when we get it optimized, it'll be closer to 40%.
Wow.
We also have some proof of concept with wearables, and then predictive and preventative maintenance on machines is another one that we're going after, because this is a perfect processor to spot anomalies. And when you look at anomalous conditions in terms of equipment, things like vibration, temperature, frequency, current draw are all perfect early indications of machine wearing. And so we can actually spot those anomalies and be able to flag it before the machine fails. So there's a lot of great markets that we can go after, and those are just a couple that we're picking off right now.
Yeah. Well, I imagine the drone market specifically, I mean, anything that's equipment in motion, like you said, that's using limited power supply. I mean, the drone market is a fascinating market. We read a lot about that. I mean, it's used obviously for lots of different scenarios, but the ability to keep the weight of the drones lighter to improve the flight time, which means maybe thinner batteries, which means then that's where it all sort of plays in, right? Is like,
Exactly.
how do you minimize that weight distribution, right?
Yeah.
Yep. So drones is a perfect one for us. It's, great for, looking at swarms, and you can do, preventative issues of, crashing or interface with birds, et cetera.
Hmm. Hmm.
Increasing the flight time, decreasing the battery weight, increasing payload capacity. There's a lot of different variables that we can utilize our technology for to really enhance the drone capabilities.
Mm. I had actually read about an interesting drone scenario on for lifeguards at beaches, where they can deploy a drone with a flotation device if they see someone out there struggling, and drop a flotation device before they can swim out there and get them and stuff. So I think we're going to see a lot of that, a lot more of that stuff happening, of course, in the drone space. You mentioned the anomaly detection for equipment. I mean, especially equipment in motion. So I'd assume like vehicles. And are you getting
Right.
more into sort of seeing? I mean, drones are robots, but other robotic space, is that getting hot for you guys?
Yeah, that's another good one
Physical
for,
AI
that's
space.
another, yeah, that's another good example for Edge AI. It's a perfect scenario for robotics, for anything in terms of, crash prevention,
Mm,
injury protection of humans. Anytime where you have a human machine interface, you'd like to have an Edge AI processor there to be able to detect that there's interference with the robotics so people don't get injured, or crash protection in terms of vehicle. Anything that requires microseconds to make decisions on, that's the
hmm.
perfect application for Edge AI. And,
Yeah.
for our, with our battery life and the form factor that we have that's extremely small, we can go
Mm,
into just about any product and be able to determine, anomaly protection or any time of crash protection, et cetera.
hmm. Yeah, for sure. So, actually, just to shift topics slightly. So, how did you become aware of the Edge AI Foundation? Who tipped you off to us?
I was aware of the Edge AI Foundation for quite some time, but I think, our VP Scott was the one who initiated the enrollment to Edge AI Foundation. But it was been since running Edge AI, I knew about it for quite some time, even when it was called a Tiny ML.
Tiny Mail.
So
Yeah, there you go.
yeah, right. So I remember it was there. Then it went to Edge AI Foundation, and then that's when Scott joined us, and then we decided to be a member.
Okay, great, great.
Yeah,
Yeah.
we kind of looked at it as like the perfect opportunity. Being a small startup company, the Edge AI Foundation has a lot of great resources for us to capitalize on, to be able to commercialize our product and get, NanoView and EMAS more widely known, because, we're a very small company that's pretty much hidden away in
Mm,
both Singapore and Australia. And so for us to really commercialize and get well known, we thought the Edge AI Foundation was a perfect springboard for us to leverage to, start to commercialize our technology.
yeah, no, that's great. Yeah, there's an incredible amount of tech there. I mean, especially coming out of universities. And like Mohammed, like your story about doing research and then commercializing it, especially in this Edge AI space where there's so much innovation and new things happening. Um,
Yes.
and then the challenge is, how do you cut through? How do you break through the noise to get people aware of this stuff? Because there is, as you know, a very well established, and Mark knows this, as he's worked in it for 40 years, very well established semiconductor market, and a lot of marketing, a lot of stuff going on out there, and a lot of established big sales teams out there. And but part of what we're trying to do too is highlight all the innovation and the companies that are doing really cool things that can be very disruptive, and to make sure that people are aware of those as well. Because I feel like this Edge AI space is really kind of the frontier, the new frontier out there. And as I
Yeah.
mentioned
Totally
recently, like,
agree.
this is the good old days. We'll look back on this Cambrian explosion of kind of stuff happening in the space, and making sure everyone's aware of it is kind of step one, right? If you're not aware of it, how can you even evaluate it? So it's good that you guys are out there, talking about what you're doing. So do you have like dev kits and stuff, or how do people like interact with your stuff?
Indeed, we do have a development kit where we have it's a board. It's an 8x7, so it's kind of like can be on the palm of your hand. right, equipped with connectors to program it, and even connectors for all the possible sensors that you want to connect it through the standard buses, like whether it's I2C, SPI, GPIO. So that's available, right? And that's what we're using to reach out to customers. But even we have a remote ability. So we have a number of these boards hosted on a remote server, so people can log in from other places and test their programs on our chip. We don't even without even sending them to them. So if they want to like have a quick check, okay, they want to upload the code and run it, then just they log into our remote development system and it gets downloaded into our chip, tested, and then sent to the metrics. If they want the board, we're happy to send that board to them. Yeah.
Cool. No, that sounds like a good thing, good scalable resource, and we'll put a link to your website in the description here on YouTube. But yeah, that's cool. So where are you going to be next physically? Are you guys coming to Amsterdam? I think you're going to be in Amsterdam at the Things Conference.
Yep, we are.
All right, cool. I'll be there too. So that's going to be quite a show. So I would say anyone out there that's kind of in the vicinity of Amsterdam around late September, you should come over and see this stuff. So see it in action.
Yeah, we're looking forward to it.
Go ahead.
Yeah, also we're gonna be in like the one in Taipei most probably as well in November. So,
yes, good.
Whoever in Asia like can travel will see us in Taipei.
Yeah. The Taipei event, November 11th and 12th, that'll be a big one, and then Things Conference in Amsterdam in September. Yeah, it's gonna be a busy fall. I'm kind of enjoying a little quiet August here. It sounds like, Mohamed, you're getting some vacation time too.
Yeah, like just like a recharge time before like the final sprint at the end of the year.
Exactly. Mark, I hope you're doing some scuba diving down there or whatever.
Yeah, I did most of mine already. We're getting ready to really go hot and heavy here in September and October, as when the vacation season winds down. We really plan on, really pushing the technology, really working on the commercial aspects of everything. So we've pretty much got all the marketing material squared away, and you should see a lot more developments coming down the path from EMASS here in the near future.
Awesome. Well, it's been great talking to you both. I look forward to meeting you in person, maybe in Amsterdam.
We have met in Milan. If you
oh, that's right. You were in Milan. That's right. Yeah, we did meet already.
Yeah, we did meet in Milan. Yeah. So hopefully see you again in Amsterdam. Yeah.
That's right. And yeah, great to talk to you both and educate the world a little bit more about EMAS and all the cool stuff that you're doing. So really appreciate it.
Thanks a lot, Pete.
All right. Thank you.